Hello everyone, welcome back to High School Tutoring. I'm your host Manny and we're going to be learning vectors using SOHCAHTOA. So we're going which is basically sine opposite hypotenuse, so sine opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. So let's just do a little bit of definitions. Opposite is the lot or the leg. It's either this like this flat bit. Oh, that's completely opposite from where the angle is. If that makes any sense. That's probably the most simple one. Adjacent is next to the angle. So you can see in this example here for cosine, we have our adjacent leg, their legs for a right triangle is there, and it's next to the angle. And our hypotenuse, which would be this value, so this bit is the resultant of our vector, we would have we would have, yeah, it would just be this line specifically. And these are how we can find one of these values. So we can either find opposite, hypotenuse, or adjacent. We could find opposite from using sine if we had hypotenuse, or if not, we could use tangent if we had adjacent. Example, and hypotenuse, we could find hypotenuse if we had opposite or adjacent. If that makes any sense. That should, but I don't know, it's pretty confusing. So if we look at inverse trigonometry, we're basically this is now showing the opposite of pretty much this. So instead of us finding these values, we're actually using these values to find the angle. So if, let's say this angle is 35, we could just plug that into tangent, opposite over adjacent, and we're just finding opposite, so we can just like do that, x over whatever times tangent 35, if that makes any sense. So inverse trig, we're now using these values to find the theta. A theta, I think, is just another way of saying it's just the other way of saying the angle. I don't know. So let's use these examples. So let's use tangent for my example. So we have tangent down here. Tangent b. So our b value, we already know, is our angle. So it's our angle from there to there. Is our, like, the internal angle there. Our b value, let's say, is what we're trying to look for. So if we want to get rid of this tangent, we have to do the inverse, which would be tangent over -1. So that would be, or the tangent quantity of -1. But remember, we have to use mathematics rules. If we do something to one side, we must do it to the other. So we'll have theta by itself equals tangent -1, and then in parentheses, our opposite over our adjacent. So if our opposite, I can actually do this example now. I have my calculator on me. But before I do this example, I'm going to do one thing. I'm going to warn you guys one thing. So what I need you guys to do is to go to mode on your calculator. So like a TI-84 Plus, I think the CE version definitely has it. I don't know about the Inspire, but we'll just keep going. You must click mode, no second, no alpha, no nothing. Scroll down to where you see radian and degree, and make sure you select degree. If we have radians, either you'll get an error every single time you use sine, cosine, and tangent, or you'll get the exact wrong answer, if that makes any sense. So just make sure you click enter on degree and then click second mode so you can quit out of it. So let's use our example here. So if we're using our opposite, our opposite is going to be, actually really quick, let me just set this down a little bit. That's better. Okay, so our opposite, let's say it's going to be 7. If I can draw. 7, and then I did not mean to close that. Okay, so we'll just have, let's just select the rectangle. Well, actually, okay, so I'll just have all that selected. Now, oh wait, okay. So, well, my apologies for that. I'll just come back to here now. So, let's say our opposite is 7. If I can draw. Okay, our opposite 7, not our hypotenuse. We don't have that, so we can just cross this out. We don't have it even mentioned here. And our adjacent, let's say, is... Nah, let's do this to scale. Let's do 10. So, 10 and then 7. And we're trying to find our theta. So, well, if we have tangent, we have our opposite and our adjacent. So, we do second tangent on your calculator. It will be next to the square root sign where you go, like, click it to go up. And so you can set your own square root. Or your own root, yeah. And we'll have tangent -1. And then click alpha, y equals n over d to make a fraction. And then we'll do our opposite over adjacent. So we'll just do 7 over 10. And then put those in parentheses, like with the tangent. Click that. And we should get about 35 degrees. So, somehow I actually did that. So this theta is about 35 degrees. And yeah, that'd be our answer right there. We'd already solved for the degrees. And if we're looking at this now, we can tell that this is northeast, as east is 0 degrees. So east would be 0 degrees. So I'm now actually going to show you guys the diagram that I've created. Or taken, kind of. And so let's say if we graph this now. So we have this. It is going right then up. So we can graph this right and then up. And let's say that would be our problem. So obviously we have 10, we have 7, 35 degrees. So we can literally just find out where we are on this diagram. So in between here, this is east of north, this is northeast, this is southeast, this is east of south, this is west of south, southwest, northwest, and west of north. So east of north, let's say, imagine we're going north and then we're going right. So we're going up we're going up and then we're going right after that. That would be east of north. That would be, we go up, then we go right. North of east, we go right, then we go up. Same thing for like southeast, we're going right, then we're going down. East of south, down, then right. West of south, down, then left. And then left, then down. And then left, then up. And same thing there, up, then left. So that would be like how that would work. So if we just graphed our thing, which is here, 10, 7, and then there's our hypotenuse or our resultant, 35 degrees, we can infer that if we do 90 minus 35, actually I'm just gonna, that will equal about 55. So 55 degrees, that would be the rest of this. So this entire bit here is 55 degrees, like going away, and 35 is the internal. So north for our math on an actual compass, this would be 0 or 360, but for us east is 0 or 360, and then south is gonna be 270, and then west must be 180. So we have to change from intervals of 90 to each one of these like actual directions. So if we were to graph this problem, we could have gone 35 degrees, northeast. That's what our answer would be for this problem. For this problem down here, if we use 10 and 7 and then 35 degrees for solving. And I hope that made sense. So let's go on to the next slide. So this is pretty much just an empty slide right now. So we'll put up the compass diagram again. We'll have that up because we're going to be using it. And then we go to practice. We have problem 1. We have problem 1 here. So our first problem, 47 degrees west of north. So if we take that, west of north means it has to go up and then right. So we can just graph that. So there's no values, we can just graph it. So if I can draw, okay, so problem 1, all right. Going up, and then west. So that would be, I'll draw a little dotted line that's kind of grayish so you guys can tell what is our actual resultant and what is our components. So west of north, obviously we're going up and then left. I meant not right, my apologies. So this internal bit, this angle here, our theta, which is just a 0 with a little streak through it, that must be 47 degrees. So if we're just solving for this now, we want to find the total angle from 0. So remember, this is 0 or 360. This is 270. This is 180. And this is 90. So if we wanted to find this angle, or if we wanted to find this outside angle, since we know it's 47, all we have to do is 90 minus 47. And then we would get around 43. Around 40, I think, no, it would be 43 degrees. So this outside bit is 43 degrees, not drawn to scale. This is not the scale. So, yeah, that would mean that this entire thing is an interval 90. And if we wanted to find the total angle, we would add 90 plus 47. To find the total angle from 0, we'd have to add 90 plus 47, which is equal to 137 degrees total. And if you wanted to find 43 again, you could just do 180 minus 137, and that'd be still 43. Now, that probably is the best way it would make sense, but yeah, I'm just going to delete this because we got to have our next problem is going to be right in front of it. So just like that, we'll have problem 2. So I hope you guys are actually taking notes, and I'm going to let you guys try this one first. So now we know that for west of north, we had to go up and then left. And then we've established it on this side as well. So if we have southwest, which would be over here, which direction would we go in first? Would we go in left then down, or down then left? How would we solve for this one? Okay, I think you guys' break is over. I hope you guys actually stopped the video and tried this. But I'm going to explain the solution now. So, we're going to be going left and then down. This is not drawn to scale at all. Okay, there we go. And there, it's just a really bad line. I don't know. It's supposed to be straight and then down. Yeah, but this will just be it. So, let's have our values now. So, we obviously know that our theta, so our 0 with the streak, is 38 degrees. So now we know that. And we know it's southwest, which we've already established, where it's going left and down. Hence, south of west. We just write southwest because it's just much simpler. So yeah, now we have that. So really, if you wanted to find, now we're gonna find the total angle. So we have 0. We have 0, 90, and 180. So it's past 180, but before 270. So we can do 180 plus 38. So 8. Okay, 1. And that would be 218 degrees. That would be our total from 0, if that makes 100% sense. And if we wanted to find this final angle, we could either use this 218, or since we are forced to go by intervals of 90, we could just do 90 minus 38, and we could find it. So look, I can prove this to you here. 90 minus 38, and 270 minus 218. You can do both of these in your calculators, but I will also do that in mine. So 90 minus 38 is 52. So if we're looking at this here, this would be 52 degrees. And then if we did 270 minus 218, we also get 52. So yeah, that just proves that, that's just like proving that there's multiple ways you can do this. So yeah, we can either use the interval of 90, or we could just use the maximum value that were before and our total entire movement. So yeah, that's really it. I could have probably gone into more detail with more SOHCAHTOA stuff. I probably should have done it, but I wanted to work with angles here. And yeah, I'm probably just gonna upload maybe a second portion of this, like a part 2, to actually use like a lot of SOHCAHTOA. This is mostly just graphing with angles. And yeah, I hope you guys enjoyed, and thank you very much, and I'll see you later. Bye bye.